Okay, so the second page, or 12 through 18, I want to go through on worksheet 5. So 12, again, is pretty basic what we've done before. You divide by 5, you've got to get your base by itself, and then once you get it in exponential form, you take the log. I took the log base 2 of 8/5 equal 3x and divided by 3. So this is what I got for an exact answer. I think my approximate looks like it's at x equals 0.23. Okay. Same with 13. 13 is an exponential. A couple ways you could solve this one, but again, since it's a base e to the x, I took natural log of this number. So log base e of pi raised to the 1 minus x equals x. And this one's similar to another one that we did, that we said we have to make sure then we have x's on both sides. So we take this 1 minus x, use the power property, bring it out in front. We had to distribute the natural log of pi to get these two terms. We collect the x terms on the same side, factor out the x, and then we can divide. So I just divided by natural log of pi plus 1 to both sides. That's how I got this answer. Some people thought you could cancel these out, and again you can't, because this in the denominator is natural log of pi plus 1. So when you put it in your calculator, just make sure you're taking the natural log of pi in parentheses. Also make sure you're putting this whole denominator in parentheses. So you should get an answer of 0.53. 14 was a problem similar to 11 and 16 because you had different bases. So you have to use change of base. You could use log base 2 since they're all 2's. That would probably be the easier way to do it. I actually took the common log as I used change of base. So I took the log of x over the log of 16, log of x over the log of 4, log of x over the log of 2. And when I did that, I had to realize that this was 2 squared, so I brought the 2 out in front. This was 2 to the 4th, so that became 4 times the log of 2. And so then I noticed that I have denominators that all have log 2's in them. So to get them to be the common denominator, I multiplied this term by 2 over 2, this term by 4 over 4. Now I could have multiplied everything by 4 log 2 if I wanted to as well. So there's many different ways you could do that, but I decided to get the same denominator. So then I have the log of x, I have 2 log x's and 4 log x's. So when I put all those together, I have 7 log x's on the top because I'm adding them together. In the denominator, my common denominator was 4 log of 2 equals 7. So then I multiplied by 4 log 2 to both sides to get this. Then I used my power property. That became x to the 7th. This became 2 to the 28th. And since you had 2 common logs equal to each other, then you knew that what you were taking the logs of had to be equal. And then I raised each to the 1/4 power. Okay? So many different ways to do this problem, but that's one way. Like use a change of base, then have to get a common denominator. Adding the numerators together, I had 7 log x's. When you get to this point, you realize that you have to get rid of this denominator. So I multiplied by 4 log 2 times 7 is 28 log 2. I used the power property. That became 2 to the 28th. That became x to the 7th. And then to solve for x, we had to raise it to the 1/7 power. That gave me 2 to the 4th, which is 16. Now, other ways to do that one, you could have decided you wanted to do a log base 2. So you could have said log base 2 of x equals log base 2 of 16, and log base 2 of x over log base 2 of 4, and then plus log base 2 of x, you don't have to do anything with that, equals 7. Log base 2 of 16 is 4, so you'd have log base 2 of x over 4, log base 2 of x over 2, plus log base 2 of x. And then again, you either could get a common denominator, or you could say, let's just multiply everything by 4. So I get log base 2 of x plus 2 log base 2 of x plus 4 log base 2 of x equals 28. And then how many of these do you have? You have 7 of them. Divide by 7. And again, 2 to the 4th will equal x. 2 to the 4th is 16. This way is probably easier if you think if they all have a base of 2, that you realize that log base 2 would be the easier one to do. If you didn't, you can do common log. It's just then you also have to do some power things and get common denominators. 16, same thing. You could have done that as log base 3 of x and log base 3 of 9 and done it that way. Or you could do it this way and do common logs like I did on my sheet. Either way, we should come out to the same answer of 1.37. Okay, so whichever way you want to do 16. It's similar to 14 and it's similar to 11. All right, the other one I want to talk about though is 15. If you look at number 15, this one's a little bit harder to put in like 13, where you could say log base e of this equals x. Because now you have 5 to some weird power and 2 to some weird power. So easiest thing to do there is use the property that says if you have the log of one thing and it equals the log of something else, you know that what you're taking the log of, as long as the bases are the same, those two things have to be equal. Well, we're just going to do that backwards and say if those two things are equal, we have two exponential things that are equal, we know their common logs have to be equal. So I'm going to say that the log of this equals the log of that. Then, you, just like we did before, use the power property, bring that out in front. The power property here, bring that out in front. Distribute the log of 2 here. That's what I got here. Distribute the log of 5 here. That gave me those two terms. Get your x terms on the same side. So I added 2x log 5. I subtracted the log of 2. Factor out your x and divide. Now when I divided, I actually simplified a little bit. I took the log of 5 minus the log of 2 with the log of 5 halves. And when I divided by this, this became 5 squared. So I had log of 2 plus the log of 25. When I put them together, I get the log of 50. So if you didn't want to put them together, that's fine. If you had all of this divided by the log of 2 plus 2 log 5, that would be fine. But all of us should get the same answer of 0.23. And then quickly, and I do the same thing with 18. 18, same thing. Okay? 17 though, let's make sure we remember that's that u thing again. So I don't like this 2, so I multiplied everything by 2. So this side just was left here, this was a 2. E to the negative x is like 1 over e to the x. So to get rid of that, I multiplied everything by e to the x. Don't forget, e to the x times e to the x, you add the exponents, you get e to the 2x. Plus 1 equals 2e to the x. That now is a quadratic. That's my u. That's my u squared. So I factored it. U was 1, so now I have to set e to the x equal to 1. So this is kind of, once you get to that quadratic, that's a review. So look over all of these. We'll try to go over some in class and make sure that you're ready for your quiz.